In this video, we're going to talk about the derivative of trig functions. We have two foundational functions that we need to talk about. We have the derivative of sine of x and the derivative of cosine of x. And what we find from our derivative rules is that the derivative of sine is cosine, and the derivative of cosine is not plain sine, but it's actually negative sine. All right. In the supplementary videos, you will see where these derivatives actually come from. Okay. What I want to do in this video is to talk about the other ones. Okay. So let's talk about what would happen if I need to find the derivative of tangent of x. Okay. Now, to kind of prove this one, it can be kind of challenging if we think of it as just tangent of x. But what I'm going to do is I'm going to pull out some identities. What you see now are the quotient identities, that we know that tangent of theta is the same thing as sine over cosine. And I can use that to my advantage here. So instead of writing tangent, I'm going to write this as sine of x over cosine of x. What that will allow me to do is to think of this as actually quotient rule because you have division. I can say my numerator is sine of x, and I can find the derivative of sine of x by using the rules above. Let's say the derivative of sine is cosine. And then I can use my denominator is cosine, and from above, the derivative of cosine is negative sine. So from here, what I can do is I can take the derivative if I apply quotient rule. Remember, you have to be very careful with quotient rule. Order matters. So remember, you always want to start with the derivative of the numerator. So we're going to say f prime times g. So this is going to be cosine of x times cosine of x minus, now we have to pair the derivative of the denominator with the numerator. So this would give me negative sine of x times sine of x. And to finish quotient rule, we need to have the denominator squared. All right. Now, from here, there's a good bit of simplifying that I can do that actually is pretty valuable. Okay. So what I have here is cosine times cosine. So that is cosine of x squared. So 2 copies of cosine. Over here, you can see 2 negatives. I can turn that into a positive. And again, I can say sine of x squared. We'll recopy the denominator down here. All right. So one thing I do want to talk about, okay, is a little bit of notation that some of us may not have seen or not as familiar with, okay? What you see is you have cosine of x squared. Another way of writing that is saying cosine squared x. So I can put the square with the function, okay? Now be careful. I'm not saying this. I am not saying you can just square the variable, square your angle here, okay? So what I'm saying is that you can say cosine of x squared or cosine squared x, all right? So you'll see me kind of transform this into this notation, which is not the same thing as just putting the square on the angle or the x, okay? All right, so let's take a look at what that actually kind of looks like here. I'm going to say y prime is cosine squared x plus sine of squared x. I haven't really done anything profound here other than kind of show you a different notation that some of you might not be familiar with, okay? Now, I can't cancel my 2 cosine squareds from here and here, okay? Because I do have addition. But what I can do is apply a Pythagorean identity. Right here, we see sine squared plus cosine squared is equal to 1, which is exactly what I have here in my numerator. So that whole entire numerator simplifies down to 1. So this is actually 1 over cosine squared x. And that looks really good, but there's actually one more identity I can apply. I can apply the reciprocal identities. The one that applies here is that I have cosine in the denominator. So what we know is that cosine in the denominator is actually the same thing as secant. So instead of writing cosine in the denominator, I can write secant, and because cosine's squared down here, I can square my secant. So what do we get out of all of this? Well, I get to say that if I need to take the derivative of tangent, that was my original function that I started with, okay? I can say the derivative of tangent is actually secant squared x. And what you have up on the board is actually the proof of the derivative of tangent. All right, so let's take a look at one more proof. So we're going to try and find the derivative of cosecant of x. Again, we're going to rely on some reciprocal identities. Right here, we know that cosecant is 1 over sine. So instead of actually looking at cosecant, I'm going to look at 1 over sine of x. Okay? Now, again, I'm going to think about this as quotient rule because I have division. I'm going to say my numerator is 1, and the derivative of a constant is always 0. And then my denominator is sine of x, and the derivative of sine from the previous slide is cosine of x. Okay? All right. Now I'm going to run quotient rule. So I'm going to take the derivative of my function, and remember the derivative of the numerator always goes first. So I need f prime times g. So 0 times sine of x minus the derivative of the denominator times the numerator. So I'm going to say this is cosine of x times by 1. All over the denominator squared. Denominator is sine, so I'm going to say this is sine. I'm just going to go ahead and write sine squared x. Okay? And then again, there's a decent amount of simplifying that I can do. I know that 0 times sine is going to be 0. And then I have negative cosine times 1, which is this negative cosine, all over sine squared x. Okay? All right. So what can I do with this? Well, let's pull up another identity here. I see a cosine in my numerator and a sine in the denominator. And why I pulled this up is I was thinking, oh, I see a cotangent because there's a cosine and a sine. But notice that there's an extra sign. There's 2 copies of sine down here. So what I can do with this is I can actually write this as negative cosine of x over sine of x times 1 over sine of x. Because when you multiply fractions, it's sine times sine, which is sine squared. That's exactly what I have here. Okay? How that helps me out? Well, we just saw that cosine over sine is cotangent. So I can replace cosine over sine with cotangent. Now, don't forget to carry the negative along. So this is negative cotangent of x. And then from above, we can say, oh, 1 over sine is cosecant. So I can replace 1 over sine with cosecant. And again, we just found and proved the derivative of cosecant. So if I need to know what the derivative of cosecant is going to be, now, I have this in a different order than how I kind of remember it. I normally remember it as negative cosecant x times cotangent of x. So I kind of flip the order up here, okay? But now we know what the derivative of cosecant is. All right, so what you see now is a list of all the derivatives, okay? So in this video, we put up the rule that derivative sine is cosine, and derivative cosine is negative sine. We also proved that the derivative of tangent is secant squared, and the derivative of cosecant is negative cosecant cotangent. what you will be doing in your assignments this week is actually proving the derivative of secant and the derivative of cotangent. Okay? Now, to make life easier and more efficient for us, we really do have to know what these are to be successful. Okay? I hate to use this word, but memorize is a big thing for these. Okay? One thing that helps me is to know that all of my C's, cosine, cosecant, and cotangent, if you pull out these three, all three of those have a negative in the derivative. So all the C's have negatives. Okay, so that's one thing to kind of keep note of. Okay, all right. In the next video, we'll actually apply these instead of just proving them.